So today we're going to understand binary mathematics, and that's the learning objective. Um, so binary mathematics is a fundamental aspect of computer science and digital technology. It is based on the binary number system, which uses only two digits, 0 and 1. These digits represent off and on states, respectively, and are the building blocks for all operations in digital electronics, data processing, programming, and communication systems. Binary mathematics allows computers to store, manipulate, and process data efficiently using simple electrical signals that can be in one or two of two states. So the binary number system is a base 2 numeral system. Unlike the decimal system, which is base 10, which uses digits from 0 to 9, binary uses only 0, which represents off or false, and 1, which represents on or true. Each position in a binary number represents a power of 2 from right to left. For example 1, let me see what, yeah, 1011. 2 equal 1 times 23 plus 0 times 22 plus 1 times 21 plus 1 times 20, which equals 8. Plus 0 plus 2 plus 1 equals 1, 1, 1, 0, brackets 1, 0, 1, 1, brackets 2. So, so converting between binary and decimal, so binary to decimal. Multiply each binary digit by its corresponding power of 2 and sum the results. For example, 1101 squared equals 1 times 8 plus 1 times 4 plus 0 times 2 plus 1 times 1, which equals 13. Divide, divide a decimal to binary. Divide the decimal number by 2 repeatedly and record the remainders. For example, convert 13 to binary. 13 divided by 2 equals 6, remainder 1. 6 divided by 2 equals 3, remainder 0. 3 divided by 2 equals 1, remainder 1. And 1 divided by 2 equals 0, remainder 1. Therefore, 1, 13, 13 divided by 10 equals 2, 1, 1, 0, 1 squared. Computers perform calculations using binary arithmetic, which includes addition, subtraction, multiplication, and division using only zeros and ones. For example, the table shown on binary addition, 0 and 0 carry 0, and the sum equals 0. 0, 0, 1, 0, 1 carry 0, sum equals 1. 1 and 0 carry 0, 1 sum equals 1, and 1 1 carries 1, and sum equals 0 with carry. Binary subtraction. Example 1 0 1 1 take away 0 1 0 1 equals 0 1 1 0. Use of binary computing. So, data storage. The explanation of this is that all files, text, videos, and images are stored as binary. Programming, logical operations, and or not are based on binary values. Networking, IP addresses and some netmasks use binary format. Digital electronics, hardware uses binary signals, high equals 1 and low equals 0. Security and encryption, binary multiplication underpins cryptographic algorithms. And machine code, the lowest level instructions executed by CPUs are in binary. So real world examples, a pixel in a black and white image, black is stored as 1 and white is stored as 0. CPU instruction, machine code in binary, as shown in the example. Permission in Linux, RW-R-R-R translates to the binary 1101001000. File storage, a text file uses binary encoding like ASCII. Digital signals in circuits, represented by voltage levels, high equals 1 and low equals 0. The advantages of binary mathematics and computing. So it has a simplicity in circuit design, which means it is easier to represent two states on or off electronically. It is reliable, so it's less prone to errors compared to analog signals. It's faster, which means binary operations are fast and efficient. And it has a compact representation, which means that it is used in compressed and encoded formats for better efficiency. The conclusion here is that binary mathematics is the foundation of all computing systems, from storage and processing to communication and decision making. Binary numbers enable systems to operate efficiently and logically. A solid understanding of binary operations, conversions, and applications is critical for anyone pursuing a career in IT, computing, or digital engineering. So converting decimal numbers into binary numbers. The conversion of decimal, which is also known as denary numbers, into binary numbers is a foundational concept in binary mathematics. It enables humans, who typically use base 10 numbers, to communicate with computers, which use base 2 numbers for data processing and storage. Decimal numbers use digits from 0 to 9 and are based on the powers of 10, while binary numbers use only 0 and 1 and are based on the powers of 2. Understanding how to convert between these systems is essential for working in computing, programming, electronics, and digital systems. Here's an example to convert a whole number. Sorry, here's the steps to convert a whole decimal number to binary. So, number one, you divide the decimal by a number by 2, record the remainder 0 or 1. Continue dividing the quotient by 2 until it becomes 0. The binary result is the reversed order of the remainders. For example, converting 25 to binary. So reversing the remainders 11001. So 25 divided by 10 equals 11001 to the power of 2. So if you look there at the table, 25 divided by 2 is 12 remainder 1. 12 divided by 2 is 6 remainder 0. 6 divided by 2 is 6 is 3 is remainder 0. 3 divided by 2 is 1 remainder 1. And 1 divided by 2 is 0 remainder 1, which means, and then we reverse the remainders, meaning that the answer is 11001. For example, convert 43 to binary. So 43 divided by 2 is 21, remainder 1. 21 divided by 2 is 10, remainder 1. 10 divided by 2 is 5, remainder 0. 5 divided by 2 is 2, 2, remainder 1. 2 divided by 2 is 1 remainder 0, and 1 divided by 2 is 0 remainder 1. So reverse this order, making it 1, 0, 1, 0, 1, 1 to the power of 2. Real world use in computing. So the decimal value 8 is the binary conversion 1000, and the use in computing with file permissions, for example, Unix RWX equals 111 equals 7. 128 is the binary 10000000, and the use is IP addressing. 255 is 111111111, and the use is maximum byte value used in RGB color codes. Here's an example in converting in Python with Python. So you set the variable decimal number equal 25. The binary number, you use the binary function on decimal number on the variable, and then have the power of 2 there as well, and then you print out the answer to find out in SQL. All you do, decimal 25 equals binary 11001. Summary table. So programming in programming, binary values using control logic, for example, flags and masks. In networking, it uses IP addresses and subnet masks. Subnetting rely on binary representation. Digital electronics, binary defines logic gates and memory addressing. In data encoding, characters, for example, ASCII, are stored as binary values. And in security, encryption algorithms convert decimal keys to binary for manipulation. The importance of decimal to binary conversion in computing. Converting decimal numbers into binary is a key skill in computing, as it allows developers and engineers to understand how systems represent and process data, whether controlling logic in programs, managing memory, or designing circuits. Binary mathematics lies at the heart of computing technology. The hexadecimal system, or hex, is a base 16 numeral system commonly used in computing and digital electronics. It simplifies binary representation by grouping every four binary digits into one hexadecimal digit, making long binary values easier to read and write. Hexadecimal numbers are widely used for memory addresses, color coding in word design, machine level programming, and debugging. What is a hexadecimal system? Hexadecimal uses 16 digits, 0 to 9, and then A to F, where A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. Each hexadecimal digit represents four binary digits, or also known as bits. For example, 10101100 to the power of 2 equals ATHE 16. AC to the power of 16, sorry. Why is hexadecimal, why hexadecimal is used in computing? Compactness, so hex is shorter than binary and easier to read and write. Binary alignment, so 4 bits per hex digit. Clean conversion between binary and hex. Error detection, it is easier to spot errors in memory dumps or debugging processes, and common in digital systems, used in low-level programming, debugging, networking, and color representation. How hexadecimal is used. So, sorry. So, memory addressing, memory locations, memory locations. in computers are often represented in a hexadecimal for brevity. For example, a memory address might be shown as 0x3f4a instead of the long binary equivalent. For example, copy edit 0x3f4a equals 00111111 0100 and 1010 to the power 2. Um, Machine code and assembly language. Hex is used in low-level programming because it closely matches the structure of binary machine instructions. For example, a machine instruction may be represented as B800, which corresponds to a binary operation in x86 assembly language. Web design and color coding. Hexadecimal is used in HTML, CSS to define colors. For example, hashtag FF for 0000 equals red, hashtag 00FF00 equals green, and hashtag 0000FF equals blue. Each two-digit hex value represents a color channel, red, green, blue, from 0 to 255. Debugging and error codes. Programmers use hex values to debug by reading memory dumps and tracking system errors. For example, a crash error might show stop 0x000007E, helping identify the issue. Converting between binary and hex. Binary to hex example. Convert 11011110 to hexadecimal. Group into 4-bit chunks. So this makes it 1101 and then 1110. Convert each chunk. So 1101 equals D. 1110 equals E. So the result is 110111110 to the power 2 equals DE to the power 16. 1 second, guys. So, real world application. Memory addresses, an example is shown there 0x7 triple F ABCD, and the purpose is to efficiently navigate RAM or ROM. Color coded in HTML, hashtag FFF or hashtag 000000 represent white and black in web design. Assembly language MOV AX 0x3E8 control CPU instructions using hex. MAC addresses. So 00:1A:C2:7B:00:47. And the purpose here is device identification on networks. Error messages. So this is 0xC0000005 track, and this tracks and interprets system faults. Summary table for hexadecimal use in computing. So memory addressing is shorter representation of binary memory location, and the example is 0xFF3A. Web design. So this is color definitions using hex codes. For example, hashtag FFA500, which equals to orange. Assembly language encodes binary instructions in a readable format. For example, MOV-8X, 0x1F, and MAC IP configuration, network interface identifiers. This an example is 01:23:25:67:89:AB, and debugging, which displays error codes in hex format, and an example is 0x80004005. The conclusion here is that hexadecimal numbers offer human-friendly representation of binary data, making them invaluable in computing fields such as programming, networking, web development, and system diagnostics. The ability to represent large binary values in a compact and readable format helps professionals work efficiently with low-level systems and memory operations. Analyze the difference between binary, decimal, and hexadecimal numbers. So this is just a comparison between binary, decimal, and hexadecimal number systems. So understanding the differences between binary, decimal, and hexadecimal number systems is essential in computing, as each plays a unique role in data representation, processing, and communication between humans and machines. These number systems are based on different radices, or also known as bases, and are used in various levels of abstraction within digital systems, programming, and computer hardware. For example, the overview is here. Binary is a base 2, decimal is base 10, and hexadecimal is base 16. The digits used for binary are 0 and 1. For decimal are 0 and 9, and for hexadecimal are 0 to 9, and A to F, which equates to 10 to 15. Also known as machine level language, decimal is known as human standard number system, and hexadecimal is known as compound but compact binary representation. So the binary number system is used by computers internally due to compatibility with two-state logic, on-off and true-false. Each digit is a bit. Binary is longer in length compared to decimal and hex for the same value. For example, 13 to the power of 10 equals 1101 to the power of 2. Applications is using digital logic circuits, memory addressing, and CPU instructions. Decimal number system. So this is a standard number system used in daily human activities. It is based on the powers of 10 and easy for humans to interpret but inefficient for computers to process directly. For example, 1101 to the power of 2 is 13 to the power of 10. Applications is in user interfaces, financial systems, and printed outputs. Hexadecimal number system. So this is a compact form of binary. One hex digit equals four binary digits, often used by programmers and engineers for readability and based on the powers of 16. For example, 1101 equals D to the power of 16. And 110 to the power 2 equals DB to the power of 16. Applications is used in memory addresses, color coding in HTML, CSS, and machine code, and debugging. Detailed comparison with conversion examples. So the number 10 decimal is 1010 in binary and A in hexadecimal. And the explanation is that 10 and decimal 10 equates to binary 1010 and hex A. 15 is 1111 and is the decimal hexadecimal F. 255 is 1111 and this is double F in hexadecimal. And 16 is 10000, which is 10 in hexadecimal. Advantages and limitations. So binary is ideal for computers, um, simple hardware implementation. However, the limitation is that long and difficult for humans to read. Decimal is natural and easy for humans, but it's not efficient for binary hardware, and hexadecimal shortens binary representation and is an easier debugging, but it requires conversion to and from binary for processing. Use cases in computing. So binary is used for machine level operations, memory storage, and logic gates. Decimal is used for user input and output, financial calculations, and display screens. And hexadecimal is used for memory addresses, web color codes, assembly language, and error codes. This shows how hexadecimal compresses long binary sequences into shorter, more manageable format without losing accuracy. For example, decimal, the value 255 is in length 3 digits. Binary is 11111111 is 8 digits. However, hexadecimal is FF, which is only 2 digits or letters. Binary, decimal, and hexadecimal number systems each have distinct characteristics suited to different functions in computing. Binary is fundamental to computer architecture. Decimal aligns with human readability, and hexadecimal serves as a bridge, offering both compactness and better human interpretability of binary. Understanding how and when to use each system is vital for efficient programming, debugging, data representation, and low-level system design. The hexadecimal number system is commonly used in computing because it provides a more human readable and compact representation of binary values. Since one hexadecimal digit equals 4 binary digits, converting from hexadecimal to binary is straightforward and crucial in many computing tasks such as memory addressing, assembly line programming, and digital logic design. To convert a hexadecimal number to binary, replace each hex digit with its 4-bit binary equivalent. This is a table from the hex to binary, and this is something that will be good for you to look at and memorize for your assessment. I'll give you a couple of minutes to just have a quick look at that and note it down if you want.
Yes, Mr. Hamza, we're done.
Oh. So, example, convert 3F hex to binary. 3 in hex is 0011 in binary, looking at that table before, and F is in hex is 1111 in binary. So the result 3F to the power of 16 will be 0011 and 1111. And converting A9 to binary, A is 1010 and 9 is 1001. So A9 to the power 16 will be 1010 to the power to the power 2. Converting 1C7. So 0001 is 1, C is 1100, and 7 is 0111. So 1C7 to the power 16 will be 0001, 1100, and 0111. Real world application in computing. So memory addressing Next example is 0xFF. Binary equivalent is 1111, 1111. And the purpose is that it refers to last address in a 1 byte range. RGB color codes. Example is hashtag FF0000. Binary equivalent is 1111, 1111, 0000, and 00000000. And the purpose is to represent your reg in web design. And machine code slash debugging B80400 is a hex example. And a binary equivalent, you guys can have a look at it. I don't think I should need to read it. And the purpose is assembly language instruction bytes. Python code here for conversion. So the hex number has been set to A9. Binary number uses the binary function, uses the int function, and puts the hex number to the power of 16. Z field keeps it to 8 bits as it says in the comment, and then you print the binary number out. So the output is hex A9 equals binary 101 Again, here's a summary table of hex to binary as shown before. The conclusion here is that converting hexadecimal numbers to binary is a fundamental skill in computer science, enabling professionals to interpret low-level data efficiently. Hex is used for its compactness and readability, while binary is used for actual processing and logic operations. This conversion process bridges this conversion process bridges human readable code with machine level operations and is essential in areas like programming, system architecture, and digital electronics. Here are the references for the books that the information has been gathered from. Again, it'll be good for you guys to do some further reading with this in preparation for your assessment. And again, the usual information refer to the ebooks and journals on this Moodle for this unit. Further reading will be good, and any queries, questions, kindly email the following email or ask me on the chat or in this lesson. And submission of the assignment to be done on the following email again. And the assignment submission is after 2 weeks of the completion of the units and its delivery. So we have 2 sessions scheduled for next week, and after that, I think that might be it. I will make sure and keep you informed of the group chat. But yeah, thanks for your time, guys. And I'll speak to you guys next week, hopefully.
Yes, thank you, Mr. Hamza.